Imagine waking up, grabbing your morning coffee and scrolling through your feed
Yeah.
and finding out that the master architectural blueprints for, well, the most valuable technology on Earth didn't get stolen by some state-sponsored hacker syndicate.
Right, no complex heist.
Exactly. They weren't exfiltrated through some crazy zero-day vulnerability. Instead, they were just accidentally uploaded to a public internet bulletin board by a tired engineer making a routine Friday afternoon-style software update.
Which is, it's wild. That is exactly what happened in the AI industry on March 31st, 2026.
It really is wild. And today, you and I are doing a deep dive into this massive accidental leak of Anthropic's Claude Code source code.
Yeah, it completely shatters the illusion we have about how these multi-billion-dollar AI labs actually operate.
Oh, completely.
We assume everything is locked behind impenetrable digital fortresses, right? Air-gapped servers, biometric security, all that.
Yeah, like something out of a spy movie.
Exactly. But at the end of the day, a $60 billion company is still subject to the mundane reality of human error in a deployment pipeline.
And that's exactly why our mission today is very specific. We are treating this leak like a highly technical treasure map. We aren't going to dwell on the corporate PR statements or the apologies. We are going to open up the hood and look at the exact underlying architectural blueprint of a production-grade AI agent.
Because that's where the real story is.
Exactly. We're going to explore its multi-agent orchestration, its unique memory compaction systems, the secret anti-espionage defenses they built directly into the code base, and really what this exposure reveals about the true future of software engineering.
The stakes here are fascinating, because what this leak conclusively proves is that the future of artificial intelligence isn't just about, training bigger language models with more parameters.
Right. The model isn't everything.
Exactly. The LLM, the brain, is just one component. The real magic, and honestly Anthropic's actual competitive moat, is the complex, highly paranoid orchestration harness built around that model. That is what we are unpacking.
Okay, so let's start with the mechanics of the breach itself, because understanding how this happened requires looking at how modern developer tools are distributed.
Yeah, we have to look at NPM.
Right. Anthropic published version 2.1.88 of the Claude Code tool to the public NPM registry. And, for anyone listening who might not spend their days deep in JavaScript or TypeScript, NPM is the node package manager.
It's the standard. It's the default global public directory where developers share, distribute, and download software packages.
Right. It's basically the backbone of modern web and server development.
Absolutely. When Anthropic wants developers to use Claude Code on their local machines, they package it up and push it to NPM. A developer simply types npm install an Anthropic A Claude Code into their terminal, and the system pulls down the application.
Easy enough. But the fatal error occurred during that specific packaging step.
Yeah. When Anthropic released version 2.1.88, they inadvertently included a massive 59.8 megabyte file known as a source map.
And a 59.8 megabyte text file is absolutely massive.
Oh, it's huge for a text file.
I've looked at the technical postmortems of this, and the source map is totally the smoking gun. But let's break down mechanically what a source map actually does.
Sure.
So when Anthropic's engineers are writing Claude Code, they are writing in TypeScript. They have clear variable names like, handle file read error. They have extensive comments explaining their logic, and their code is spread across thousands of neatly organized files.
Right, human-readable stuff.
Exactly. But when they compile that code to ship it to the public, they run it through a bundler that transpiles it into JavaScript and minifies it.
And minification is brutal. It strips out every single space, every line break, every comment.
It just squashes everything.
Yeah, it takes a nice descriptive variable like handle file reader and renames it to it literally squashes thousands of files into one dense, continuous, totally unreadable string of characters. And the goal there is twofold, right? Make the file size as small as possible so it downloads instantly, and obfuscate the logic so competitors can't reverse engineer the proprietary code.
That's the idea. But if you obfuscate the code, you create a massive headache for your own internal developers.
Right, because debugging becomes a nightmare.
Exactly. If a user reports that the app crashed on line 1 of that giant minified file, the Anthropic engineer has absolutely no idea where that error actually maps back to in their original TypeScript files.
And that is the exact problem a source map solves.
Precisely. A source map is essentially a JSON file that acts as a translation dictionary.
Okay.
It contains an incredibly complex string of base 64 variable length quantities. And what that does is map the exact row and column of the minified code back to the exact row, column, variable name, and original file of the human-readable TypeScript.
Wow, so it's a complete index.
Yes. And crucial to this specific leak, modern source maps have a property called source content. If enabled, it literally embeds the entire unminified source code of the entire application directly inside the map file.
So the debugger doesn't even need access to the local file system.
Right. That's all baked in.
So by uploading the source map with that source content property included, Anthropic essentially zipped up their entire internal code base, over 500,000 lines of proprietary logic across 1,906 TypeScript files, and attached it to the public release.
Yep. It's the equivalent of handing out a heavily encrypted hard drive to the public, but taping the decryption key directly to the casing.
That's exactly what it is. And a security researcher named Chaofan Shou caught this almost instantly.
He was fast.
Very fast. He flagged the presence of the .map file on X, formerly Twitter, and the post just exploded to over 28 million views within hours.
And the moment I saw that post, my first thought was, well, why couldn't Anthropic just immediately unpublish the package?
Right. I mean, if I post a bad photo online, I just delete it. You'd think a tech giant could just send a kill command to NPM and wipe version 2.1.88 from the servers.
They did unpublish it eventually, but you are running into the fundamental immutability of internet infrastructure.
Meaning you can't really delete things once they're out there.
Right. The NPM registry isn't just a single server sitting in a closet in San Francisco. It is backed by massive content delivery networks, or CDNs, distributed globally.
Right, for speed.
Furthermore, there are millions of automated build pipelines, continuous integration servers running GitHub Actions or Jenkins that are constantly pinging NPM every single second.
Looking for updates.
Looking for the latest package versions to compile corporate software. So the moment the package hits the registry, thousands of machines automatically pull it down before a human at Anthropic even realizes they made a mistake.
So the propagation is just instantaneous.
Yes. The source map was extracted, the original TypeScript was reconstructed using standard reverse engineering tools, and the completely unredacted codebase was uploaded to GitHub.
And it became the fastest downloaded repository in GitHub history.
It did. By the time Anthropic's legal team mobilized to issue DMCA copyright takedowns, the repo had already amassed 84,000 stars and 82,000 forks.
Wow.
The genie wasn't just out of the bottle, it had been cloned tens of thousands of times.
Now, Anthropic was very quick to clarify that no sensitive customer data was breached.
Which is an important distinction.
Definitely. There were no API keys, no user chat logs, no database credentials exposed. This is purely a leak of intellectual property.
Right, they lost their secret architecture.
Which brings us to the actual contents of the leak.
Wow.
Because when developers started tearing into those 1,906 files, they realized that the industry's perception of how AI coding tools work was completely backwards.
Totally backwards. We tend to focus entirely on the foundation model, right? Like Claude 3.5 Sonnet or Opus. We treat the model as the product.
Sure, because that's what we interact with.
Exactly, but the leak reveals that the model is effectively being treated as a raw commodity internally. The actual product is the highly sophisticated agentic harness built around it.
Let's dissect this harness, because the tech stack choices here are fascinating. Claude Code isn't built on Node.js, which has been the industry standard runtime for JavaScript for over a decade.
No, it's not.
Anthropic chose to build this on Bun.
And that architectural decision speaks volumes about the performance bottlenecks of AI agents. Node.js uses Google's V8 JavaScript engine, which is highly optimized for web servers. But Bun is a much newer runtime.
It's written in Zig, right?
Yes, written in the Zig programming language, and it uses Apple's JavaScript core engine instead of V8.
Okay, so why switch?
Bun's primary selling point is blisteringly fast startup times and incredibly optimized system-level input-output operations.
But why does an AI need fast system I/O? I mean, it's just generating text, right?
If you are just chatting with a web interface, sure. But Claude Code is an autonomous software engineer. When you ask it to, find the bug in my authentication flow, the harness has to execute hundreds of file system operations per second.
Oh, I see. It's actually digging through your hard drive.
Exactly. It has to scan directories, stat files to check modification dates, read file contents, spawn child processes to run tests, and then pipe the standard output back into the AI's context window.
That's a lot of heavy lifting.
It is. If you use a slower runtime, the latency of those file system operations compounds, and the agent becomes agonizingly slow. Bun gives the harness the bare metal speed required to interface with a massive enterprise codebase in real time.
Okay, that makes sense. And the presentation layer is just as complex. I saw in the leak they were using React and Ink.
Yeah, that surprised a lot of people.
When I read that, it broke my brain a little bit. React is a library for building web pages rendering HTML in a browser. How and why are they using React inside a text-based terminal?
It requires a massive paradigm shift in how we think about the command line. Historically, terminal programs are just streams of text. You run a command, it prints text downwards, and you scroll to read it.
Right, very static.
But Anthropic wanted Claude Code to have dynamic, updating UI elements. They wanted progress bars that actually fill up, interactive menus where you can use your arrow keys, expanding and collapsing file diffs.
Like a real application window.
Exactly. And Ink is a custom renderer for React. So instead of taking React's virtual document object model and translating it into HTML for a browser, Ink translates React's state changes into ANSI escape codes.
Ah, ANSI codes. Those are the hidden control characters that tell the terminal emulator to, like, move the cursor up 3 lines and change the text color to green.
You got it. It allows Anthropic to build a stateful, highly reactive user interface directly in the terminal window, utilizing all the component-based architecture of modern web development.
That explains the sheer volume of code dedicated just to the infrastructure. The leak metrics showed 29,000 lines of code dedicated entirely to the tool system. And that isn't AI inference logic. That is purely code written to define input schemas, validate the parameters the AI tries to use, and handle permission gating.
And that's not even counting the query engine.
Right. There are 46,000 lines for the query engine, which manages the LLM API calls, the token caching, and the multi-agent coordination.
To contextualize that, 75,000 lines of code just for tooling and querying is the size of a fully featured, standalone enterprise application.
It's a whole operating system, essentially.
Pretty much. It completely redefines the F1 racing analogy often used in tech. We look at an F1 car and marvel at the engine, assuming horsepower is the only variable that matters. The foundation model, Claude, is the engine.
Right.
But if you drop a 1,000 horsepower engine onto a track without a chassis, aerodynamics, specialized tires, and real-time telemetry, it is going to spin out and crash on the first corner.
It'll just tear itself apart.
Exactly. The harness is the aerodynamics and the telemetry. It dictates how efficiently the raw intelligence of the model is applied to the messy reality of a developer's file system.
And the benchmark data actually supports that analogy perfectly. When the developer community started cross-referencing the leaked architecture with independent performance tests, a surprising fact emerged.
What did they find?
So on Terminal Bench, which is a highly respected benchmark evaluating how well AI agents execute terminal commands, Claude Code doesn't even crack the top 10.
Really?
Yeah, it ranks 39th on raw Happy Path capability scores.
Wow.
Yet, Anthropic reportedly wins over 70% of enterprise head-to-head evaluations against OpenAI's equivalent tools. The math just doesn't seem to add up until you look at the error handling.
Ah, the error handling. Yes.
Wow.
The leak revealed that approximately 60% of the entire code base is dedicated strictly to failure recovery.
60%.
Yes. Benchmarks test what an AI does when everything goes perfectly, but enterprise development is never perfect. The harness operates on the fundamental assumption that the AI model will hallucinate, it will format its tool calls incorrectly, and it will attempt to execute commands that crash.
So the harness acts as a highly protective supervisor.
Precisely. If the LLM outputs a malformed JSON payload requesting a file read, the harness doesn't just crash the application and throw an error to the human.
It catches it first.
It catches the parsing error, formats a hidden prompt saying, "You missed a closing bracket on line 4, please fix the JSON," and feeds it back to the model before the human even sees the mistake on their screen.
The resilience is completely invisible.
Invisible and robust. The harness employs exponential backoff for network timeouts. It uses intelligent context truncation when the token limit approaches, and rigorous output validation using schema libraries like Zod.
Wow. So the reason Claude Code wins enterprise contracts isn't because the model makes fewer mistakes. It is because the harness intercepts and resolves 99% of those mistakes autonomously.
That's exactly it. And that invisible resilience leads perfectly into one of the most fascinating architectural revelations in the leak. How Anthropic solved context rot.
Context rot. Yeah, anyone who has used an AI for a long coding session knows exactly what that is.
Yeah.
Eventually, the model just loses its mind.
It gets confused.
Yeah, it forgets what file it was editing 10 prompts ago, or it starts hallucinating variables that you already deleted.
Yeah.
But the leaked code details a 3-tier architecture that Anthropic calls the skeptical memory layer.
And context management is really the holy grail of agentic AI right now. If an agent cannot maintain an accurate worldview of the code base as it evolves, it becomes a total liability.
Right.
Anthropic's 3-tier system divides memory into working memory, episodic session memory, and long-term project memory. But the critical innovation here is the operational philosophy behind it.
Which is?
The agent is explicitly programmed to distrust its own memory.
Now, I want to push back on the efficiency of this a little bit. The leak shows the AI treats its own internal context as a mere hint, not a concrete fact.
Yes, a hint.
So if the AI remembers that a function is called fetch data, it won't just blindly write a new script calling fetch data.
Yeah.
It forces itself to run a file system check to verify the function name hasn't changed,
Correct.
but doesn't constantly second-guessing itself and pinging the file system introduce massive latency. It sounds incredibly computationally expensive compared to just trusting the cache.
You are identifying the exact engineering trade-off Anthropic had to make. Yes, running a stat or a cat command on a file before every major edit adds milliseconds of latency. But consider the alternative.
Okay.
Let's say the AI reads a file into its context window. It takes 2 minutes to formulate a complex refactor. During those 2 minutes, you, the human developer, open that exact same file and manually rename fetch data to get user data.
Ah, a race condition.
Precisely. If the AI lacks skeptical memory, it executes its refactor based on stale information. It confidently overwrites your manual changes, effectively deleting your work, and introducing syntax errors because it referenced the old function name.
The developers looking at the leak actually called these ghost writes.
Ghost writes, exactly. By enforcing a trust but verify protocol, the harness hashes the file or checks the modification timestamp right before the write execution.
So it does a final check.
Yes. If the file is dirty, it aborts the write, rereads the fresh file, and recalculates its entire plan. The slight latency hit is the price paid to eliminate catastrophic ghost writes.
It's treating its own memory as lossy, which is a surprisingly biological way to architect software.
It is very biological.
And speaking of biology, the memory management system utilizes another organic concept. Hidden in the code base is a background process officially named background consolidation, but the internal variables and comments literally refer to it as auto-dream or sleep.
The sleep function. It is a brilliant solution to the problem of a polluted context window.
How does it get polluted?
Well, when an agent works on a repository for days, the context window fills with digital noise, failed terminal commands, stack traces of bugs that have already been fixed, dead-end thought processes.
That's a bunch of junk.
Yeah. And if you continuously feed that bloated, noisy history back into the LLM, the attention mechanisms of the transformer model get diluted. It struggles to separate the core architectural rules of the project from the noise of yesterday's typos.
So how does the AI sleep? I mean, how does it clear that out?
The harness actually tracks your usage patterns. After approximately 24 hours of elapsed time and at least 5 active coding sessions, it waits for an idle period. When you are interacting with it, the system quietly forks a hidden independent subagent in the background.
Wait, it spawns a clone of itself while I'm not looking.
Yes. And this subagent doesn't write new code. Its sole purpose is to perform a reflective MapReduce operation over the entire messy history of the last 24 hours.
Like it's sorting through the day's events.
Exactly. It merges redundant observations, detects and resolves contradictions, discards the stacked traces of resolved bugs, and condenses the core, verified learnings into a highly optimized, bounded memory state.
It's literally replicating human REM sleep.
It really is.
Consolidating the day's experiences, moving the vital structural knowledge into long-term memory, and flushing the short-term noise so it wakes up with a clean, sharp context window.
And this consolidated memory is physically materialized in the file system. It writes these compressed insights to a plain markdown file called memr.md.
I noticed that detail in the leak, and it strikes me as remarkably transparent. They rely heavily on these simple text files. Memory.md holds the automatic learnings, and Claude.md holds the manual rules the developer sets.
Right, rules like always use double quotes or never use the any type in TypeScript.
Exactly. Using Markdown files is a masterful UX decision. It demystifies the AI's brain.
It does. A developer doesn't need some special dashboard to see what the AI knows. They can just open memory.md in their text editor.
And if the AI drew a wrong conclusion during its dream phase, the developer can literally just delete that line of text, and the AI's memory is instantly corrected.
So simple, but so effective. But the implementation of Claude MD revealed a much deeper mechanical secret. The leak showed that the harness doesn't just read the claude.md instructions once when you start the program. It forcefully reinserts the entire contents of that configuration file into the hidden system prompt on every single turn of the conversation.
Wait, every single turn? Why?
That prevents alignment drift. In a massive context window, recent instructions heavily outweigh older instructions. If the rules of the project were only declared at the very beginning of a 100-turn conversation, the LLM's attention mechanism would gradually forget them.
It would get distracted by the immediate bug it's fixing.
Exactly. By prepending the core rules to every single execution loop, the harness ensures absolute compliance.
But I mean, appending a document to every single API call brings up the massive issue of cost.
It does.
If I ask the AI to refactor a massive million-line legacy codebase, and it has to hold the project rules, the consolidated memories, and the current file state in its mind all at once, wouldn't processing that massive context over and over again completely bankrupt the user in API token costs?
It absolutely would, and it would likely hit the computational limits of the model itself really fast, which introduces the necessity of the workforce architecture.
Workforce architecture.
Right. The leak explicitly details that Claude Code does not attempt to solve large problems with a single monolithic prompt or a single agent instance. It utilizes a highly advanced multi-agent orchestration framework.
This was the most complex part of the leaked code for me. It looks like it spawns a whole team of specialized agents.
It does. Let's use the analogy of a high-end restaurant kitchen.
Okay, I like that.
If you order a complex tasting menu, the head chef does not cook every single component of every dish simultaneously. The head chef acts as the orchestrator. They receive the order, break it down into discrete components, and delegate highly specific tasks to the line cooks.
The sous chef, the saucier, the pastry chef.
Exactly.
Right. The line cook searing the steak doesn't need to know the recipe for the dessert or the history of the restaurant. They just need the steak, the pan, and the specific instruction for medium rare.
Exactly. Claude Code operates the exact same way. When you issue a massive refactoring command, the main instance acts as the coordinator agent.
The head chef.
Right. The coordinator analyzes the architecture, breaks the refactor into a directed acyclic graph of dependencies, and then spawns parallel worker agents to handle isolated chunks of the code base.
And this is how they solve the token cost problem, by restricting what each worker agent can actually see.
Yes, through a mechanism called context snapshots and prompt caching. Modern LLM inference relies heavily on key-value caching at the GPU level. The massive baseline knowledge of the project, the overall architecture, the clade.md rules, is processed once and stored in the server's fast memory.
So they don't have to reprocess it.
Right. When a worker agent is spawned, it doesn't recalculate the attention matrices for the entire history. It simply references that cached memory and is only fed the specific files it needs to edit. This prevents the token costs from multiplying linearly with every parallel task.
That is brilliant. But here is a massive technical hurdle.
Yeah.
If you have 5 worker agents running in parallel, editing different parts of a code base simultaneously, how do they share information? They have isolated context, so worker A doesn't know what worker B is doing.
The leaked code shows they utilize a shared Scratchpad directory and communicate via strict XML formatted task notifications.
Why XML? I mean, I feel like the entire web development world abandoned XML for JSON a decade ago.
Why?
Why is Anthropic forcing cutting-edge AI to use an antiquated format?
It's a quirk of how large language models process tokens. While JSON is highly readable for human developers, its structure relies heavily on curly braces and quotation marks,
Right.
which can easily be corrupted if the LLM hallucinates or truncates its output. XML, with its explicit opening and closing tags like thought process and thought process, provides a much more robust boundary for the model to follow.
Ah, I see.
The harness can parse an XML tag stream in real time as the tokens are generated, whereas JSON usually requires the entire payload to be complete before parsing can begin. It dramatically speeds up the inter-agent communication.
Okay, so they are passing these XML nodes back and forth through the Scratchpad, but I still have to bring up the issue of divergent state.
It's a big issue.
If worker A is refactoring the database schema, and worker B is simultaneously writing API endpoints that rely on that schema. Worker B is writing code against the old version of the database, while worker A is changing it. When the coordinator tries to merge everything at the end, the whole application's going to break.
Managing optimistic concurrency in multi-agent systems is incredibly difficult. The leak indicates Anthropic handles this by forcing the coordinator agent into a rigorous reconciliation loop.
How does that work?
The worker agents do not commit their changes directly to the main branch. They generate proposed diffs. The coordinator then loads the newly proposed schema from worker A, cross-references it against the proposed API endpoints from worker B, and if it detects a conflict, it rejects worker B's diff.
And then what?
It respawns a new worker with the updated context to try again. It mimics a git merge conflict resolution, but completely automated.
The coordination logic alone is just staggering. And as if a parallel workforce wasn't enough, researchers dissecting the codebase found a hidden, unreleased feature flag for something called Ultraplan.
Ultraplan is wild.
When I read the specs for Ultraplan, it sounded like we were transitioning from AI tools to autonomous AI engineers.
Ultraplan represents the frontier of what researchers call test-time compute. Currently, the industry expects low-latency AI. You press enter, and the model starts streaming an answer in 500 milliseconds.
Right, instant gratification.
Ultraplan intentionally breaks that expectation. It is a high-latency, deep reasoning mode designed for massive architectural planning.
The codebase explicitly references offloading these tasks to an unreleased massive model codenamed Opus 4.6, and it lists supported think times of up to 30 minutes. You give it a prompt, and your terminal just goes dark for half an hour while the AI thinks.
And during those 30 minutes, it isn't just generating text slowly. It is operating in a remote, sandboxed runtime environment.
Doing what?
It is running recursive reasoning loops, exploring multiple architectural pathways, writing prototype code, running tests against that prototype, realizing it failed, and pivoting to a new architecture.
So it's basically doing trial and error.
It conducts a multi-step scientific method. Once it has formulated a complete mathematically sound plan, it teleports that finalized architecture back down to your local machine for the coordinator and worker agents to execute.
Teleporting architectures from a remote sandbox. We now have a digital workforce that spawns subagents, creates isolated snapshots, dreams to consolidate memory, and goes offline for 30 minutes to redesign the fundamental architecture of your app.
That's a lot.
This is the exact point where my awe turns into absolute terror. If this entity has full access to my file system and can think independently for half an hour, how do you prevent it from confidently deciding that the best way to optimize my application is to, ARM-RF the entire production database?
The autonomy necessitates the paranoia. You cannot deploy an autonomous workforce without ironclad guardrails. And the leak exposes the intricate permission framework Anthropic built to restrain the harness.
How does the framework operate?
It operates on a strict 3-tier classification: allow, deny, and prompt.
But who decides what falls into which tier?
The harness utilizes a completely separate, lightweight machine learning classifier specifically tuned for risk assessment.
Oh, a separate ML model.
Yes. When the LLM proposes an action, the harness intercepts that proposal and runs it through the classifier. Low-risk operations like reading a readme file, listing directory contents, or running a linter are auto-approved. The agent executes them without interrupting you.
And the high-risk stuff.
High-risk operations like modifying network configurations, installing new external dependencies, or deleting files trigger a hard block. The harness halts the execution thread, prints a warning to your terminal, and forces you to manually type Y or N.
So it's like an automated bouncer assessing the threat level of every single system call.
Exactly. And this ties into another major safety pattern heavily emphasized in the codebase: diff not rewrite.
Right, diff not rewrite.
If you ask a standard web-based LLM to change one line in a 500-line file, it will often print out all 500 lines with the one change included. In an agentic environment, rewriting entire files is incredibly dangerous.
Why is it dangerous?
Because the LLM might accidentally drop a critical function at the bottom of the file simply because its attention mechanism drifted.
Not to mention the API cost of regenerating 500 lines of code just to change a comma.
Exactly. The diff not rewrite pattern forces the AI to output its changes in a patch format, similar to a unified diff algorithm like Meyer's diff.
So it just specifies the exact change.
Right. The AI says locate line 42, find the string max retries equals 3, and replace it with max retries equals 5. The harness then applies that surgical patch to the local file.
And if it can't find it?
If the harness cannot find the exact string the AI referenced, it rejects the patch and throws an error back to the AI. It guarantees that the AI cannot accidentally corrupt code it wasn't explicitly targeting.
Okay, the surgical diffs and the risk classifiers ease my anxiety a little bit, but that comfort evaporates when we look at the telemetry built into this tool.
Good telemetry is intense.
The leak exposed a feature mentioned over 150 times in the source code. The KAIROS daemon mode.
KAIROS is the mechanism that transitions Claude Code from a reactive tool to a proactive participant. It is an always-on background agent.
Always on.
Always on, it utilizes file system watchers like Sevens on macOS or Inotify on Linux to silently monitor every change you make to your codebase, maintaining an append-only daily log of your actions.
So it's watching me type in real time? If I make a typo in my database connection string, KAIROS sees it, runs a quick background check, and theoretically could pop up to say, hey, you misspelled the database URL, before I even try to run the code.
That is the intended utility, but Anthropic engineered it with a deep understanding of developer psychology.
Because that sounds super annoying.
It is. Nothing is more infuriating to an engineer in a flow state than an AI aggressively interrupting them with unprompted advice, the classic Clippy problem.
Oh man, Clippy.
To prevent this, KAIROS is strictly governed by a 15-second blocking budget.
How does a blocking budget work mechanically?
When the daemon detects a potential error in your code, it spins up a background thread to analyze it. It is given a hard time out of 15 seconds of CPU time.
Okay.
If it cannot definitively prove the error and generate a high-confidence patch within those 15 seconds, the thread is instantly killed. It aborts the task and remains completely silent.
Wow, just like that.
Just like that. It is mathematically constrained to only offer help when it is absolutely certain it can add value without causing distraction.
Engineering empathy through hard timeouts.
Yeah.
But I cannot ignore the sheer depth of the surveillance happening here. I read the telemetry schemas in the leak. The application isn't just monitoring the code. It is monitoring the human.
It's monitoring everything.
It logs UI interactions. It classifies language in real time. And it specifically deploys 21 distinct regex pattern matchers just to detect human frustration.
The regex matchers are fascinating. They aren't just looking for swear words. The code evaluates keystroke latency, the frequency of backspace usage, the rapid cancellation of terminal commands, and specific structural markers in the prompts.
That is so specific.
If you type in all caps or forcefully interrupt the agent's generation 3 times in a row, the regex engine flags your session state as frustrated.
This is where I draw a hard line. Measuring my hesitation, timing my backspaces, analyzing my emotional state via regex. That crosses the line from a helpful coding assistant to corporate spyware. Why does a command line tool need to know if I'm annoyed?
From a privacy perspective, your reaction is entirely justified. But from a systems engineering perspective, this extreme instrumentation is the fuel for Anthropic's data flywheel.
What do you mean?
You have to remember, Anthropic is trying to build an agent that feels intuitive and context-aware. If the AI hallucinates a bad piece of code and you immediately backspace it and rapidly type a correction, that rapid cancellation is the most valuable piece of training data Anthropic can capture.
Because it shows them exactly what went wrong.
Yes, it tells their reinforcement learning models exactly where the AI failed and how the human fixed it.
So they aren't capturing my frustration to serve me targeted ads. They're using my micro-expressions of annoyance as a negative reward signal for their reinforcement learning pipeline.
Precisely. By mapping exactly when a developer loses patience or hesitates, they can fine-tune the agent's behavioral heuristics. They can teach it when to back off, when to apologize and simplify its approach, and when to proactively ask for clarification.
It's learning how to be a better coworker.
Exactly. The entire runtime environment is fingerprinted. It is the invisible cost of having a highly personalized, emotionally intelligent digital coworker.
The cost of a personalized interface is total behavioral transparency. That is a heavy trade-off. But let's pivot from extreme corporate surveillance to high-stakes corporate espionage. Because the leak didn't just reveal engineering marvels. It exposed the active sabotage Anthropic has built into the codebase to fend off their rivals.
The AI arms race is ruthless. And the biggest threat to a company like Anthropic isn't a competitor building a better model from scratch. It's a competitor stealing Anthropic's intelligence to train their own model cheaply.
Right. And this practice is known as model distillation.
Model distillation, yes.
I want to make sure I understand the mechanics of distillation. If I'm an AI startup with a small budget, I can't afford to spend $100 million training a massive foundational model. So instead, I build a small, cheap student model.
Right.
Then I buy an API key for Claude, the massive teacher model, and I feed it millions of complex coding problems. I take Claude's perfect answers, and I use those answers as the training data for my cheap student model.
That is exactly how it works. By training the student model to mimic the probability distributions of the teacher model's outputs, minimizing the Kullback-Leibler divergence between the two, you can create a smaller model that performs almost as well as the multi-billion-dollar original at a fraction of the cost.
Which feels like intellectual property theft.
It is intellectual property theft operating in a legal gray area. To combat this, the leaked code revealed that the Claude Code harness actively deploys anti-distillation poison pills.
Poison pills. How do you poison data through a command line tool?
The harness is actually designed to detect when its outputs are likely being scraped programmatically rather than being read by a human.
How does it know?
Well, the speed of interaction, the lack of UI events, things like that. When it detects these conditions, it subtly alters the orchestration payloads.
What does it change?
It deliberately injects fake tool schemas, hallucinated variable definitions, and entirely fabricated dependency structures into its API requests.
So it's feeding the scraper a honeypot. The LLM knows to ignore the fake schemas, but the automated scraper blindly copies everything.
Yes, it is active programmatic sabotage. If a rival startup trains their student model on that poison data, their new AI will learn these hallucinated pathways.
Wow.
When someone tries to use the rival AI, it will attempt to call tools that don't actually exist, completely breaking its orchestration capabilities. Anthropic is weaponizing their own output to corrupt the training pipelines of their competitors.
That is phenomenal. It's counterintelligence built directly into the code base. And that wasn't the only covert feature. There's an operational mode in the code explicitly named undercover mode.
Undercover mode addresses a completely different kind of corporate paranoia. Anthropic engineers obviously contribute to public, open-source projects on platforms like GitHub.
Sure, they have to.
But they don't necessarily want the public to know which commits were written by humans and which were generated by internal, unreleased versions of their AI tools. They also want to hide any proprietary naming conventions or internal paths that might accidentally slip into the code.
The system prompt for this mode reads like a script from a spy thriller. It literally commands the AI. You are operating undercover in a public open source repository. Your commit messages, PR titles, and PR bodies must not contain any Anthropic internal information. Do not blow your cover. Mask all stylometric markers.
It forces the AI to scrub its own metadata and mimic standard human git commit phrasing.
It perfectly illustrates the tension in the industry right now. Companies want to leverage the benefits of open-source collaboration, but they are terrified of accidentally leaking the slightest hint of their internal IP. And yet, right next to the poison data pills and the undercover espionage modes, we have the Easter eggs. Because amidst all this paranoia and six-layer architecture, the codebase revealed a command invoked simply by typing buddy.
Ah, the buddy feature. It is a fully persistent, Tamagotchi-style virtual companion built directly into the terminal interface.
The juxtaposition is almost comical. You have a system doing multi-agent MapReduce operations over abstract syntax trees, and the engineers took the time to write logic that generates 18 different species of AI pets, rendered entirely in ASCII art, that live in your terminal while you code.
It's great. It tracks its own state, requires interaction, and generates persistent personalities. It was apparently scheduled as a surprise release for Easter, but the leak unveiled it prematurely.
It humanizes the monolith. It reminds us that behind the $60 billion valuation and the poison pills, this code was written by developers who still appreciate a good terminal hack.
Developers will be developers.
Always. But as we move into the final segment of our deep dive, we have to look at the massive, immediate fallout. The vault is wide open. The source map was decoded. The architecture, the espionage tactics, the memory structures, they are all public domain now. What are the concrete ripple effects of this exposure?
The immediate consequences were a cybersecurity nightmare. When you publicly expose the complete, unredacted architectural blueprint of an agent that inherently runs with elevated file system permissions on enterprise developer machines, you hand malicious actors a perfectly annotated map of vulnerabilities.
Because prior to March 31st, if a hacker wanted to compromise Claude Code via a prompt injection attack, they were effectively blindfolded. They had to guess how the model parsed its input.
Exactly. Now they can read the exact regex patterns and parsing logic line by line. Cybersecurity research firms like Straker immediately immediately pointed out that attackers no longer have to rely on brute force prompt injections.
They can be surgical.
It's very surgical. By studying the precise mechanics of the four-stage context management pipeline we discussed earlier, attackers can craft highly sophisticated payloads designed specifically to survive the AutoDream memory compaction process.
Wait, explain how that works. How does a virus survive the AI's sleep cycle?
If an attacker hides a malicious prompt inside an open-source library that the developer asks Claude to read, a normal system might flush that context out after a few hours because it's irrelevant.
Right.
But if the attacker formats the malicious payload to mathematically align with the weighting algorithms the AutoDream subagent uses to define important long-term memory, the subagent will intentionally compress that payload and write it permanently into the memory.md file.
Oh my God. The attacker has effectively planted a persistent silent backdoor that survives indefinitely.
Yes. And the vulnerabilities weren't just theoretical. The leak exposed a critical flaw in the configuration loading order officially tracked as CVE 2026-33068. The way the harness-loaded workspace trust settings allowed a malicious repository to bypass security prompts entirely.
So it wouldn't even ask for the Y or in confirmation.
Exactly. Anthropic rushed a patch in version 2.1.53, but the window of exposure was disastrous.
And that window of exposure was aggressively exploited through massive supply chain attacks within hours of the leak. Because Anthropic immediately unpublished the official version 2.1.88 from NPM, developers who were desperate to see the leaked code started searching for unofficial mirrors.
And attackers flooded the internet with them.
They did. A Trojanized version of the immensely popular Axios HTTP client was pushed to developers who happened to run updates during a specific 3-hour window.
The Trojan contained a cross-platform remote access tool, so developers trying to peek at Anthropic's secrets ended up handing total control of their workstations over to hackers.
And you mentioned a specific vector used by a threat actor known as Pacifier 136, involving something called typo squatting. I want to break this down because the mechanics of dependency confusion are insidious.
Please do. It's one of the most effective attacks happening right now.
So when developers analyze the leaked source code, they see import statements referencing internal Anthropic packages that the public has never seen. Libraries with names like audio capture NAPI and color diff NAPI.
Right. Internal tools.
These are private packages hosted on Anthropic's secure internal servers. But Pacifier 136 immediately went to the public NPM registry and registered those exact identical package names.
Right.
Right now, they just uploaded empty files containing malicious install scripts.
Okay, I see where this is going.
If a curious developer downloads the leaked Claude Code base and tries to compile it on their local machine, their package manager will look for audio capture NAPI. It can't access Anthropic's private server, obviously, so it defaults to the public registry, finds the attacker's fake package, downloads it, and executes the malware during the build process.
So the developer's machine literally requests the malware.
It's terrifying. Cybersecurity firm Zscaler also reported a waves of fake GitHub repositories claiming to host the cleaned Claude leak. These repos are highly engineered traps containing Rust-based droppers.
What do those deploy?
When executed, they deploy VDAR Stealer, which extracts browser cookies and stored credentials, and Ghost Socks, which turns the infected developer machine into a proxy node for illicit network traffic.
The security fallout is a catastrophe. But what about the business fallout? Has Anthropic completely lost its competitive moat? Did they just hand OpenAI, Google, and the open source community the exact playbook required to clone their 70% win rate architecture?
The cloning process didn't just begin. It accelerated at breakneck speed. Competitors are utilizing a clean room reverse engineering technique.
Explain the clean room concept.
A team of engineers analyzes the leaked source code to extract the abstract concepts, how the multi-agent DAG works, how the KV cache is structured, and writes comprehensive technical specifications without copying a single line of proprietary code.
Okay.
They then hand those clean specs to a second team of engineers who have never seen the original leak, and that second team builds a new application from scratch.
Which legally insulates them from copyright infringement while allowing them to perfectly replicate the architecture.
Exactly. I've already seen an open source project called Klarst gaining massive traction. It's a complete re-implementation of the Claude Code harness, rewritten entirely in the Rust programming language for even better memory safety and speed.
Patrick McGinnis, a highly respected AI industry analyst, summarized the impact perfectly. He argued that this leak forcefully commoditizes the agent harness in the exact same way that DeepSeek's R1 model commoditized the concept of AI reasoning earlier in the year.
So it's no longer a secret advantage.
No. Prior to this leak, skeptical memory, proactive daemon modes, and XML scratch pads were Anthropic's closely guarded advantages. By the end of this quarter, those features will become the baseline, mandatory standard for every open source and closed source developer tool on the market.
That sounds like a fatal blow to Anthropic's enterprise dominance.
It would be if Anthropic were standing still, but the consensus among experts is that while this is a humiliating and expensive setback, it is not a fatal wound.
Because they're already moving on to the next thing.
Exactly. The leak itself contained the evidence of their velocity. Hidden in the configuration files were internal code names referencing models that don't even exist publicly yet.
Right, I saw the references to Opus 4.7, internally codenamed Fennec, and Sonnet 4.8, codenamed Capra.
And just days prior to this NPM disaster, a separate leak from their content management system revealed preparations for a staggering 10 trillion parameter foundation model called Mythos.
10 trillion. That is unbelievable scale.
Anthropic is iterating at a speed that is difficult to comprehend. By the time the open source community or rival labs manage to perfectly clone and stabilize the architecture of Claude Code version 2.1, Anthropic will likely be deploying version 3.0.
Backed by reasoning models vastly more capable than what we're analyzing today.
Exactly. They lose the element of surprise, but they still maintain the momentum of their internal engineering talent.
Which brings us to the ultimate synthesis of everything we've explored today. From a mundane 59.8 megabyte source map file left on a public server, we have unschooled the entire architectural philosophy of the next generation of software engineering.
We really have.
If there's one definitive truth to take away from this entire deep dive, it is that the era of the chatbot is dead. The era of you ask the AI a question and it streams a response is officially over.
We have crossed the threshold into the era of autonomous invisible execution. It works when you are not looking.
Exactly.
The leak proves that the raw intelligence of the neural network is no longer the sole differentiator. The true power, and honestly the future of the industry, lies in the highly structured, intensely paranoid, and deeply instrumented scaffolding built around the model.
The harness.
The harness. An architecture capable of spawning parallel workforces, strictly managing its own divergent states, treating its own memories with cryptographic skepticism, sleeping to compress its knowledge, and patiently monitoring your keystrokes to understand your emotional state.
And that reality brings up a deeply provocative thought that I want to leave you with today. Think about the sheer scale of the engineering we just discussed.
It's massive.
This leak revealed that Anthropic had to construct an intricate, paranoid system that constantly monitors human hesitation, actively deletes its own unreliable memories, operates undercover to hide its tracks, and utilizes complex psychological heuristics just to successfully help a developer write a React component without breaking the file system.
It is an unprecedented level of behavioral and systemic scaffolding.
Exactly. So if this is the level of invisible, highly instrumented psychological architecture required just to build a functional coding assistant, what kind of unseen autonomous scaffolding is going to be required when these exact same agentic systems transition from the terminal to the consumer?
That's the real question.
When these multi-agent orchestrators start managing our personal finances, analyzing our health records, or handling our daily communications?
The leap from code management to life management changes the stakes entirely.
Are we truly prepared for consumer technologies that know exactly when we're losing our patience? Systems that silently debate in the background for 30 minutes about the optimal structure of our daily routines?
I don't know if we are.
Tools that actively and autonomously decide what parts of our digital history are worth moving into long-term memory, and what parts of our lives are just noise to be permanently discarded while we sleep.
It's a staggering premise. The blueprints for that level of autonomy are out there now. The mechanisms are no longer theoretical, they are open source.
It is definitely something to mull over the next time you interact with an AI, because it turns out that secret recipe accidentally left on the NPM bulletin board. It wasn't just a technical schematic for how to build a better software tool. It was a high-resolution preview of exactly how the machines are preparing to manage us.